Then let's move to the next presentation. So the next presentation is from Dr. Po-Chuan Yang from Risen. He will speak about heterojunction towards the industrialization. Paul is currently the general manager, Heterojunction business unit at Risen Energy. Paul also has more than 18 years of experience with amorphous silicon material and heterojunction silicon solar cells. He has a PhD from National Taiwan University in electronics engineering. He got his degree in 2008. Paul started with AU Optronics and worked on amorphous silicon and crystalline silicon heterojunction solar cell also at Neo Solar Power. So Paul, please start your presentation. We are very excited to hear from the long-time supporter of heterojunction.
Hello?
Yeah. Please start your camera and
yeah, but I cannot share my screen because other people is using the screen.
Min, can you help him?
Okay, right now it's fine. Okay, so hello everyone. Microphone is okay?
Yes.
Okay, so I will start my presentation. Hello everyone. Thanks Taiwan News to give me this opportunity to talk here. I'm Po-Chuan Yang from Risen Energy. I'm in charge of Heterojunction business unit in Risen. Today, I would like to share the heterojunction industrialization status in Risen. This is my agenda. So there are 4 parts. The first one is to introduce Risen Energy, and the second is the heterojunction status in Risen. Next one is heterojunction industrialization status in China. Final is my summary today. Risen Energy is founded in 1986 and started solar business from 2002. So we have a long history in solar business. So right now we have 14 gigawatt module capacity and over 8,000 employees. And last year, our revenue is 16 billion US dollar. And our headquarters is at Ninghai in China, very near Ningbo. So we have 17 sales service centers in all over the world, and also 6 production bases right now. We also have business with over 30 countries. In 2020, we shipped several modules, including like the first one is in China, has 27%, and then Vietnam roughly 13%, and the third one is Brazil and Spain, roughly 11%. So it covers almost 50% sales in 2020. There are 5 main business in Risen, which is the main business is PV product, cover from cell, EVA, backsheet module, and the ribbon junction box. And we also have a PV power project, like residential project, the EPC, and the solution provider, like energy storage solution, smart microgrid solution, a lot of total solution for new energy. And the next one is new material, like anti-PID EVA, white EVA, PO fin. And finally is the LED business. We have home lighting, educational lighting, different kinds of condition lighting. And in Bloomberg tier 1 manufacturer right now, we are the number 6. We have 14 capacity right now in the world. So next one is, let me introduce our heterojunction status in Risen. In Risen, we started heterojunction activity from 2018. And at that time, we decided to go for heterojunction technology. So we built 100 megawatt cell pilot line. As you can see, the main tool picture in the right side of the slide. And at the meantime, we also upgrade one module factory from PERC to heterojunction. The capacity is 500 megawatt. So let us talking about a roadmap about to the high efficiency. So our pilot line we built 2 years ago is small size wafer. So right now we will retrofit this pilot line to larger wafer. And the first G12 wafer will come out at the end of this year. And so we strongly believe that using the larger wafer for heterojunction, it will benefit for the cost. And for the cell structure, right now we are doing heterojunction bifacial structure. And in the future, we think heterojunction with perovskite tandem cell will become the future. And this is real data in our production line. We can easily achieve 746 millivolt open circuit voltage in production. That means the total Zena is smaller than 10 femtoamp per cm square. So as everyone knows, amorphous silicon is the best passivation material, and the open circuit voltage and the Zena total has an exponential relationship. That means if you tried a little bit more effort for the total Zena in the cell, it is very easy to achieve 750 millivolt open circuit voltage. So what we are doing is clean the wafer surface more carefully and decrease the wafer thickness, and also do a lot of new technology during the CVD deposition. So we can easily achieve right now 754 millivolt right now. And this is also real production data for the surface recombination velocity. So heterojunction with amorphous silicon double side passivation result in super low surface recombination velocity. So heterojunction can use 100 micrometer wafer and keep the cell efficiency without degradation very large. So another key point for heterojunction is if you are using 100 micrometer wafer, N-type wafer, that means it is cheaper than 160 micrometer P-type wafer. So the only thing we need to take care for the thin wafer is for the module process. Actually, during the cell production, using thin wafer is almost no problem. The yield rate is almost the same, like just like a thick wafer. So that is why Risen Energy, we are right now we put a lot of effort on the module process, how to treat the thin wafer, how to use the thin wafer to cost down the total cost of the heterojunction module. So after 2 years learning curve, Risen Energy, we develop our own heterojunction technology without using a turnkey solution. And we achieved 24.6% average cell efficiency and a maximum 24.9% with 24 hours, 7 days operation. The cell line total yield is larger than 98%. So in these 2 years, we also sold a lot of heterojunction module. We called it Seeger module. The total shipment amount is roughly 200 megawatt in this 2 years, which in our calculation, which is the biggest heterojunction module maker in China in these 2 years. At the same time, we also achieved some champion module data, like the right side of the slide. This is 606 watt. And we just announced a new heterojunction power output data is larger than 720 watt in roughly 1 hour ago. So everybody can check this data on website of in Risen. So let us talking about the advantage of the heterojunction technology. I think it have a super low temperature coefficient and a very high bifaciality compared to other technology. And also no PID, no light-induced degradation. So it results in very good reliability. So combine all of this advantage, heterojunction can provide, I think it's the best energy yield in commercial solar product in the market. And also that means it is the most promising technology of the LCOE. And we strongly believe that heterojunction can be the future if it go to the 10 gigawatt level, and the module cost can decrease very quickly. So that means the LCOE can be better compared to PERC. So basically, we optimize all of the module in our production to make sure our heterojunction production successfully. The first one is laser cutting process. We optimize the cutting depth, heat affected zone, and the split wafer method. To the most important is we establish an effective method to monitor and to optimize the cutting process during the production. So that means we can monitor the laser cutting loss during module production. That is very important to make sure your production is very stable. The second one is we optimize the flux and the ribbon and the solder and the soldering parameter to find the best process window and make sure the reliability at the same time. For the equipment part, we upgrade and retrofit the existing module tool originally for PERC cell, and so that can makes some differentiation with compared to other company. We can keep the know-how in our company by ourselves. We also use the same module design to allow customer to use the same racking system in the solar power plant to make sure they can using heterojunction module easily without changing the system design. Finally, we also have a very well-trained module team. They are familiar with heterojunction production over 2 years. Yeah, this slide just showed our heterojunction module can pass 3 times IEC, and the degradation of the power is lower than 2%. And we also built a demo site to collect the real power output data in our headquarters. The energy yield of bifacial heterojunction outperforms 7.5% compared to bifacial PERC module. And if you are talking about compared to the monofacial PERC module, heterojunction outperforms roughly 14.4%. So if we use this 7.5% energy yield data to put into our LCOE module, we can find that the LCOE of the heterojunction is comparable with PERC right now. It will be more competitive when gigawatt level heterojunction production is coming. And then this slide just shows our customers' heterojunction power plant, 25 megawatt in China, Baicheng. So finally, let's talking about the heterojunction industrialization status in China. During 2019 to 2021, we call it exploration period. And during these 3 years, a lot of new solar player joined heterojunction, and they invest megawatt level, build a lot of pilot line, and several material equipment also try to localize the material and the equipment and to cost down. And in the next 2 years, we think heterojunction will go to gigawatt level investment, and the production, that means a lot of production line will come out, and the cell cost will reduce gradually. The most important thing is we so-called tier 1 solar company will start to expand the heterojunction, and the supplies and the markets will expand quickly. So after 2024, we think heterojunction capex will be comparable to PERC cell, and we will see more and more larger than 10 gigawatt level investment at that time, and the heterojunction will become mainstream after 2024. So this is my summary. Risen Energy started heterojunction activity from 2019, cell line from 2019, and in Q4 this year, we achieved 24.6% average cell data and the maximum 24.9. Total yield rate is larger than 98%. The energy yield outperforms bifacial PERC 7.5%. The LCOE of Risen heterojunction is comparable with PERC now. It will be more competitive when gigawatt level coming. So we predict that heterojunction will be the mainstream in 2024. Okay, thank you.
Okay, thank you very much for your very nice insights into heterojunction. You have also finished your presentation on time, so we can still save some time. But I will ask one question, which was also posted in the chat room. So, what is the roadmap for the wafer thickness at Risen? So, where are you looking at?
Right now, we are looking for 120 micrometer thickness at this moment, and we will go for even thinner very soon, but that depends on our module technology. So we are trying our best to develop new module technology, which is suitable for thin wafer, especially for heterojunction low temperature process at this moment.
Okay, so that means you are already at 120 microns right now with your production.
In pilot production.
Yeah,
no problem.
Okay. So thank you very much for your presentation. Please stay online and use the chat function. There are already a few more questions, and also there might be some more. So please answer in the chat function so that you can also keep the chat area active. And thank you very much again for the presentation.
Thank you.